Hey, so let's see how to do the schematic part of it of your lab. So the way the lab is designed is you create a schematic, then you simulate it with the same test bench that you have written for the Verilog. You're doing this so that you can understand what's the relation between a schematic and how it is performing with respect to your test bench and things like that. So basically to make sure that your schematic is working as you want, we are doing the same procedure. For simplicity purposes, I won't be designing the entire circuit of the lab, but I will just be designing an AND gate or maybe an AND OR gate, and then converting it into a Verilog file, and then you can follow the same procedure that you did in the video one with the test bench setup and all. I will leave you with Verilog files at the end of this. So to start it, let's go to File, click on New, then there is this thing called block diagram slash schematic file. You want to click that and click OK. So once you do this, it should generate something called block1.bdf. You can don't worry about the name, you can save it later. So if you see the symbol, the AND gate symbol, this is basically the symbol tool. So if you press that, it should give you a drop down menu, something like this. That should basically have all the libraries or symbol libraries for your quarters. So once you click on that, you want to go to primitives, and these primitives are the things where we reside. So inside logic here, you should basically find all your gates. So and 2 is a 2 input AND gate, and 3 is a 3 input AND gate, 4 input, and so on. And different gates, you can just click on them and you can actually know about it. So if you just right click on it, it will basically show how the symbol looks like. For example, B and 2 is an invert, it has two inversions for both of its inputs, and it's an AND gate, and so on. So let's just do an AND OR 3 input function maybe. So if I just do AND and click OK, I can place it here. So if I do control plus scroll up, it should basically zoom things. So once that is done, I'll click on this again. That should give me another drop down menu. I'll do an OR gate. Yeah, 2 input OR gate, and just click OK. So I have an OR gate here. So basically my function has 3 inputs, 2 go to AND and 1 go to OR, and things like that. So let's make the internal connections like we wanted to. So start from this pin position and make sure you get this square. So if you look at that joint there, that basically says it is joined. If you get that square, that basically means it is joining that particular pin. And then just hit escape and it should go away. And this is the only connection I care about. If you want to delete them, you can just right click on it and hit cut. It should cut things for you. You can change the instance names by right clicking on it, going to properties, and you can change it to and whatever you want. So I'll just keep it as and change this to or, and that's all. So once you do that, let's put that connection back. So it starts from here, goes to this position, right? So hopefully you understood that part. So let us assume that this is my entire circuit, but in your case you'll have to do the entire adder. But if this is the entire circuit, now I want to give inputs and outputs to it. So I go to symbol tool again. It should give me a pop-up like this. This time I'll close the logic that I have opened before, and I'll go to pin. So inside pin, you should have an input pin, output pin, and a bidirectional pin. For simplicity purposes, or for the beginning labs, you'll basically be using input pins and output pins. So I'll click OK here because I need 2 input pins. So input pin 1 goes here, and the other one goes here, and then I need an output pin for my output. So I'll go to pins again, click on output, click OK, and put it here. Oh, I forgot I might need one more input pin for my third gate. So let's do another input, click OK. I'll just keep it here for now, but I'll make the corrections. So I'll click escape, go to the node tool, and then select this node to this node, this to this, and this gate to this gate. So that should basically complete my connections if I just, put this out here. So that's the circuit I want to synthesize as of now. So once this is done, I would hit Ctrl S or just go to file and save it. For now, I want to save it as schematic 1, maybe schematic 1, and it saves as a BDF file. If you look here, BDF is basically block diagram file, but you want to simulate it. So the easiest way to do it is to convert this block diagram file into a Verilog file, and the way to do it is go to file, click on create update, and if you hit on create HDL design file from current file, that should basically ask you if you want VHDL or Verilog. I would choose Verilog, and that's the one we are using for this lab. And here, if you look at this, you have an option to name it whatever you want. I'll just leave it as schematic1.v. That's the default name it comes up with, and I'll click OK. So once I do that, it completes its procedure. It says its compilation is done, and in the same folder that you have been working on, you should basically be able to see your file. So if you can't, let's click on open. Let's go click open. You should go to the same file. You can see a .v file called schematic.1. Just click open. You should basically see an assign statement with a synthesized wire of an AND gate of pin 1 and pin 2. That is our AND gate in this case. So it has pin name 1, pin name 2. You can change those names if you want. And then pin name 4 is ORed with a synthesized wire. So this is your synthesized wire that you see in between. This is pin name 4, and your output goes to pin name 3. That is basically here. So if you want to simulate this file, just plug in this particular module, just like you do the rest of the test benches like you saw in the previous video, and you should be able to simulate it pretty easily. That's what the schematic part meant. For the submission purposes, you need not actually submit the simulation report for your schematic, but you want to compile it, you want to make sure this schematic actually works, and you need to submit that. Hopefully that is clear.